All right, basically, again, what we're doing is a quick little review because these are new notes, I think better suited for online versus the on-class ones. And we talked about the idea again now that here we are dealing with lists, and then we're going to be using the idea of pointers and dynamic memory to create list structures. So looking at this, and the idea that we had is the list. And again, if this was an array, there would be the indexes. So each member there would have its own index. And we talked about the fact that with arrays had limitations, one of them being we had to set how many members are in the array when we first start. Whereas with the idea of pointers and dynamic memory, we can turn around and make it dynamic, put as many members on there as we want. And so what we're going to be doing is we're going to be looking at this kind of a list structure using pointers. Looking at this, then the operations, obviously, insert, add a node into the list, delete the node, retrieve a value, it's in the node, and transverse, go through the whole node. And so again, the idea of insertion, looking at this, we're going to insert at a certain point, depending on exactly what type of list. And then we talked about is that there are two types of lists that we use quite a bit. One of them being a queue, and a queue, exactly as it would be, is you had people lining up at the bank. You'd have the first person coming in, next person would come in, stand in the queue, next one, and next one. So with the queue, the person at the front of the line is going to get serviced first, and then as new people come in, the last one in is going to be the last one out. So this is a last in, last out concept. And we talked about that, and that is going to be a queue. The other way of looking at a list is we talked about the fact of stack. And thinking of a stack of plates, dinner plates, you would stack them up. So you put the first one on, and then the second one on top of it, add the next plate on top, next plate on top. And that the idea is that when you're going to take one off of those, you'll take it off of the top. So what this is the last one in is going to be the first one out. And that's going to be our, one is the queue, the other is a stack. Boy. So looking at that, we're going to be dealing with this. But for the rest of this lecture, we're going to be doing a generic linked list. We're just going to create the linked list and see how we manipulate the pointers to create it. So again, deletion, retrieve the value or not, and then delete that element or that node off of the list. Again, retrieval, just going through and finding a thing in. So what we're going to be doing for our linked list is that we're going to have two structures. We're going to have here, this is kind of a control structure. The whole idea of this is going to be our anchor. And as our anchor, what it's going to be doing is that's going to hold the address of, in this case, the first element or the first node of our list. And we're also going to have the count. So looking at that, this is the control structure. Then this structure here, these are our actual nodes, N-O-D-E-S. Those are our nodes, or the elements of our list. And these will be replicated over and over. So we'll have a number of nodes, and they're all going to be connected. So again, this is the goal, this is where we're going at. We're going to be doing this in C, obviously. So with doing this, we're going to be having structures. So a user-defined variable type, and our user-defined variable types are going to have our control structure and our node. So we look at this, and this is how our control structure is going to be built. And looking at this, we're going to have 4 variables in there, an integer for count, and then what we've got is 2 addresses holding an address to a type node. So again, looking at that, if this was a 32-bit world, what we're going to have is 4 bits for this, 4 bits for that, and 4 bits there. So what the control structure is going to take up 12 bytes, not bits, 12 bytes. And then what we have is our structure for the node. Now, because again, we talked about making this generic, what we're going to be doing here is simply have one address pointing to data going to be type void, so we can use the same code over and over and just delineate or differentiate what void pointer points to. And then the other is going to hold the address to another node of the same type. So looking at that, what we have there is something generic. Now, for the assignment, for those of you that looked at it already, we're not going to be doing this. We're going to be having our node structure is going to actually have the data embedded in it, and obviously then also the pointer to another node. So looking at something like that, what we can have now is a structure, and then it can have anything in there. So it could have had char, last name 30, char first name 30, int age, and float height. I don't know. Looking at this, and then some name for it, but the idea, this is just a structure. Now, to make this a node, the only thing we've got to do different is add one more variable, and that variable is going to hold, say we called this node. All that's going to be is going to hold an address of type node. So call that next or link or whatever you want. And as long as that's put inside the structure, that structure then becomes a node item, because what we have here is an address, the ability to point to a memory location that's going to hold another structure of the same type. And this is similar to what you're going to be doing in the assignment, but the assignment's only going to have one variable besides the pointer variable. Besides the link, it's going to have just the one in there, and it's going to be an integer.